Today's video will give several examples of code that has various levels of robustness. Hello, I'm James Helfrich. The robustness quality metric tells us the level of assurance we have the given block of code works as expected. This video will give several examples of code at various levels of robustness and show how that additional levels of scrutiny give us more assurances that our code works as expected. Robustness is the degree in which a function class or component has been tested to ensure that it functions as designed, and we have 5 levels of robustness. The best is proven. I've mathematically proven that the code works as expected. We only really do this in exceptional circumstances, but sometimes it's required. One below that is resilient. We've done systematic white box testing. Usually this means it's been thoroughly unit tested. One below that is strong. We've done systematic black box tested, which means we have a robust set of test cases, and we've run through this through the public interfaces. One below that is tested. We've done rudimentary testing. And finally, fragile. We have not done any systematic testing or no testing at all. So let's take a look at some examples of these. First of all, an example of fragile. Here I have a GPA class, and I have a get and a set, and I have a GPA, which is stored as a short. Now, I want to see how it's fragile. To demonstrate the class is fragile, we could do one of 3 things. Perform no robustness analysis. We can execute the program in a small number of trivial test cases, or we could just do a visual inspection. This third option is called face validity, and we'll pursue this option. So here's our implementation in C++. I'm going to take a look at it, and I'm going to say, yeah, looks good. Okay, next level is tested. Provide an assurance that the GPA class is tested. So first of all, I'm going to create an ad hoc driver, and I'm going to facilitate running through a whole bunch of test cases, and I'm going to try a couple of these different things. I'm going to say 4.0 and 3.5 and 2.4, and I'm good to go. And so here's a bunch of test cases that I ran through, and it looks good, so I'll have a degree of confidence. Now notice, I have a much higher degree of confidence in this than I had with fragile, but still my testing leaves a lot to be desired. All right, next is strong. So strong, I'm going to have to come up with a systematic test plan. And so I'm going to take a look at some typical cases, some error conditions, some boundary conditions. And once I have all these, then I'm going to create a function that is going to allow me to run through all these test cases in succession. Now, once I've run through all these test cases, then I can establish a strong level of robustness. The final example here, I'm going to have the same exact code, and I want to find resilient. So I required me to do white box testing. So first of all, I'm going to have a systematic test plan, and I'm going to exercise each of these test cases one at a time. So I'm going to create a function, and this is one of my test cases, middle valid range. Now observe here that I'm accessing the member variable GPA directly. I'm going to set it to 2000, then I'm going to do set 1.2345, and then I'm going to verify that my GPA.GPA is 12345, and that's because I'm using a short here divided by 1000. I'm going to have the right number. Okay, so this is one test case. Now here's another test case and another test case and another test case and another test case. In fact, I have to create a separate test function for each of my test cases that I previously identified. When I run through all these, now I have resilient level of robustness. And this is basically what we're looking for from most of the class will be right when we create unit tests. Now we can learn more about this in example 2.4.1, .2, .3, and .4 in the robustness chapter of the software design textbook.